Okay, so today we're talking about inverses of a function. Okay, that's our topic, inverses of a function. So let's take a look. So the first example is, take a look at f of x and g of x. And they say, are they inverses of each other? Okay, so are they really inverses of each other? So what we can do is just check real quickly. So f of x is the same thing as y, right? Or g of x is the same thing as y, right? So we talked about is, so let's switch x, y into y, x. Okay, so let's look at this chart. I go 0, -2, -2, 0. Yeah, those have been switched. Do you agree? 0.5, -0.75. Yeah, that's been switched. 1.5. So I'm switching the x's and the y's all the way through. They've all been switched, haven't they? So I'd say yes, that f of x and g of x's are inverses. Yeah, they're definitely inverses because the x and the y got switched all the way around. So they're inverses of each other because if you go the other way and switch g of x, it turns into f of x, right? You switch g of x, it turns into f of x's. So they're really inverses of each other. F is the inverse of g, and g is the inverse of f. Yeah, Zoe.
But doesn't that work for
Yes and no. Let's hang on to that question. It's a great question. Okay. So in this case, it definitely did, right? Right, definitely did. Okay. All right. So let's look at this. Okay, we don't have the interactive video, but we don't really need to. Okay. Use the coordinate plane below to plot two sets of points. Okay. So first of all, I need a point. Doesn't really matter. Let's go ahead and grab a point. Okay. 2, 4. Let's go 2, 4, and give me another one more set. Okay, and then 3, 1. Great. Okay, give me some other points. I just need some points around here.
2.
Okay, let's go 6. How about 6, -1? Okay, or 6, -2. Give me some more points.
5, 7.
I want to get some points over here. Give me some points.
-1, -1.
-1, -1. Good. -1, -1. Give me another point. Something.
-2, 4.
All right, -2, 4. Okay, good. Let's take all of those points. Okay. Now, so let's go ahead and write the coordinates down. So here's.
Doesn't work.
Hold on. So I've got a point at -2, 4, right? I've got a point at -1, -1. I've got a point at 2, 4. I've got a point at 3, 1. And I've got a point at 6, -2, right? That's my f of x, okay? That's my f of x. So my inverse would be f inverse of x because the x becomes the y. That's why it says the x, because the x becomes the y, right? So the inverse would be, let's see, what's the inverse of this one? 4, -2. What's the inverse of this one?
-1, -1.
It's its own inverse, isn't it? It's its own inverse, right? What's the inverse of this one?
1, 2, 4, 2.
4, 2. The inverse of this one?
1,
The inverse of this one?
-2, 6.
Good. Okay, now let's go ahead and graph or plot the inverses. So I'm going to plot those in a different color. Let's see, how about brown, okay? So I'm going to go 4, -2, that's there, right? -1, 1, 2, I'm going to go 4, +2, that's there. I'm going to go 1, 3, that's there. And -2, 6 is there, okay? Now, what we want to do next is draw a line. We're going to draw a straight line, and we're going to draw it on the line y equals x, okay? So let's draw the line y equals x, okay? So I'm going to do that with my ruler. Okay, there's the line y equals x. Am I going too fast? Everybody okay with what I got?
Yeah.
Okay. All right.
Oh my gosh, whoa.
Do you see anything?
Yeah,
What do you
it's
see?
symmetrical.
It is. Yeah, it is. Yeah. In fact, so what we're going to see is what Lana sees, and that is a point and its inverses are a reflection over this line. See that? Here's this point, its inverse is over here. Here's this point, its inverse is over here. Here's this point's on the line, right? that make sense?
We learned the non-mathematical way.
Right. So what we know about this is some big aha moment is the fact that every function and every inverse are a reflection of this line. So let's write that down. So we know that points and their inverses are reflections over the line y equals x, right? Okay. Now we can use that information to help us find inverses of lines. Now, when you think about lines, if we draw, and if we draw a line got a lot of points, right?
Yes.
It's got different points. So there's a couple ways to do it. One, you could do it the long way and get a bunch of points, switch the points, and regraph it. Okay? You could do that, okay? Right? Another way to do it is to graph it and just do a reflection, right? Another way is to switch the variables and solve it and graph it. We're going to do all three of those, okay? So let's go ahead and turn the page, okay?
Why do we have to do the long one?
Okay, turn the page. Well, we're going to see, okay? Okay, so real quick. How are a function that's inverse related? What would you put?
1, 0.
Okay. So they are reflections over the line y equals x. Good. Good. And then we'll put down what we already know, that if we have a point x, y, to get its inverse, we'd have inverse would be y, x, or we're going to switch x and y values, right? We know that, right? You guys agree with that? So let's look at table 4, right? So table 4 has the values 0, 1, 1, 2, 2, 3, 3, 4. So if we want its inverse, go ahead and fill this in. It should be easy. You should be able to do this. Should be able to do this chart in a matter of like 2 minutes, right? If we want f and g to be inverses, if we want these to be inverses, right? Then just take this chart and rewrite it down here, okay? And what are you going to do?
Flip it.
Yeah, inverse or switch them around, yeah. So you're going to have 1, 0, 2, 1, 3, 2, 4, 3.
8, 6, 8, 7.
Okay, everybody agree with that?
Yeah.
Now, if we want to graph, this is important. Here comes the hard stuff. So you got to listen. Okay, here comes the hard stuff. Now, if we want to go ahead and find the inverse of a line, the reason we make a line with x and y, okay, now this is a biggie, okay? The reason we make a line with x and y is because the x represents all of the x's. That's why we use a variable, and the y represents all of the y's, not just point by point by point, but all the points. That's why we use x and y, right? So if we want to make the inverse of a line, we just switch in all of the x and y's, we switch the variables. So if we switch the x for the y and the y for the x, we've switched all of the x's, we've switched all of the x's. So all the y. So take a look at this next example. So we have really y equals x plus 4, right? And if I want to graph that, I can graph that real quickly. Okay. All right. Oh, that was not a very straight line. Well, okay. We'll just have to live with that bad looking line. And if I started up at 4, 1, 2, 3, 4, up 1 over 1, up 1 over 1, right? Get this line right there. Agreed? If I want its inverse, so if I want the inverse
Wait, of that line?
of that line, now that line's made up of a lot of points, right?
Yeah.
One way to do it is to just simply get points and switch it. Get points, switch it, get points, switch it, your graph. That works, okay? Another way is to draw your reflection line and reflect all the points, right? That will work. Another way is just go straight to the equation, okay? So the equation, what do we do? We have to switch x and y, right? We're going to switch them all. So this equation now becomes x equals y plus 4, right? I just switched all of them. So doing point by point by point. Now, I don't want to graph this until I solve for y. And that's easy to do, right? If I have this, now all I do is I switch the x and y. Boom. Now let's just solve. So minus 4, you okay with that? Minus 4, minus 4. So I'll have y is equal to x minus 4. All right, let's graph that.
Oh, are you kidding me? I had to go to 3.
So I'd go to negative, well, yeah, I should have gone down a little bit further, right? Up 1 over 1, up 1 over 1, up 1 over 1. Okay. So this is f of x. This is f inverse of x. And let's do what Landon saw. We draw in our line of reflection. Let's see if this actually looks like it works. Does that look like it's been flipped over that line?
Yeah.
Yeah.
Yes.
Okay, now here's another thing. And I'm almost done. Okay, if an inverse really is the opposite, that means that, you ready? Watch. That means that this x-intercept is now a y-intercept over here. This x-intercept is a y-intercept because x and y switch. I'll say it again. This x-intercept now becomes a y-intercept, and this y-intercept now becomes a x-intercept because the x and y's are switched, okay? So inverse is not difficult. 26 I'm not done. 26 I'm done, okay? To do inverses, all you do is switch x and y's. That's all you do, okay? Easy, isn't it? Okay. So I do have a little, let's call it classwork, because we have a lot of times, we might be able to do trivia today, huh?
How many times?
We might be able to do some cahoots.
Check on your Broly.
National Spaghetti Day.
When we
We might have time to do some cahoots. We're doing some little cahoots today. Not that bad.
12:42.
We should do a trivia on national days.
Okay.
Only engineering kids will know that.
No, only you would know that.
And Gabe.
Go ahead and pass those back. Go ahead and pass those back. Pass it back. Pass it back. Pass
We're
it
talking
back.
about other countries.
Pass it back to Lord.
What were you saying about Tuesday? I heard he already hates Manson. Ryan.
He does?
Gilly.
Hey, how about you shut your mouth?
Easy boy. Isaac, relax. Relax, Isaac.
He hates what's it called? He hates Manson.
Hey guys, if you're chicken.
Oh, and they're like,
I got a minute for you. Under 5'6".
Yeah.
Yeah, happy birthday, Nick.
Happy birthday, Nick.